This video is on properties of exponents. So looking at our first property, we have the product of powers property. So this property is when you're multiplying things of the same base, you just end up adding the exponents. So same base is the key word. Same base can be the same number, the same variable. So in our example, we have the same base of x. So x is our base. We're going to add the exponent. So 2 plus 4, and we get x to the 6. And that's all you have to do to simplify with the product of powers property. Looking at the quotient of powers property. Okay, this is when our variables or numbers of the same base, again, has to be the same base, are being divided. That's what quotient means. You subtract the exponents. So I again have x and x, but this time my exponents are 2/3 and 1/3. So my base is x. I'm going to take the top number and subtract it from the bottom number of the exponent. So 2/3 minus 1/3, they have a common denominator, so I can go ahead and subtract them. I get a 1/3, and that would be simplified. Power of a power property is when you have an exponent raised to another exponent. So when you have that, you multiply the exponents together. So this would be an example, x to the 7th raised to the 3rd power. So we're going to multiply. So we have x to the 7 times 3 power, and 7 times 3 is 21. And that would be simplified. Looking at our next example, I combined 2 into 1 just for sake of time. Power of a product or quotient property. Again, product means multiplication, quotient means division. So when you are trying to find this, basically you're just distributing the exponent to every number and variable. Every number and variable gets the exponent. So looking at our first example, this is an example of a product because we're multiplying x times y. All I'm going to do is give each variable the exponent of a 3. So that means x cubed, y cubed, and that would be it. Okay, the quotient, same concept, except now we're dividing x divided by y. Each variable, no matter where it is, on top or bottom of the fraction, it gets the exponent of a 4. So x to the 4th divided by y to the 4th. Now you can't simplify it with the properties from the previous page because they are not the same base. So you just leave it like that. We're done. The last two properties, we have the zero power property and the negative exponent property. So the zero property, we've been talking about this for a while. Any number or variable raised to the 0 power equals 1. No matter what, it equals 1. So 5x to the 0 power equals 1. The reason it works is because of our quotient of powers property. Remember, that was the second property on the first page. That is the property that told us if we have things being divided that are the same base, we subtract the exponents. Well, when I subtract the exponents, 5 minus 5 gives me that x to the 0. Well, we also know that if I'm dividing something by itself, that equals 1, and that is why x to the 0 equals 1. Now, negative exponent properties. You can have no negative exponents. They are not allowed. Not allowed. That's super important. No matter what you do, you cannot have negative exponents. So, to get rid of them, okay, all you're going to do is you're going to put that term in the numerator if it's in the denominator, or the denominator if it's in the numerator. You're just going to flip it to the opposite part of the fraction. So I have two examples for you. So example 1, I have x to the negative 7. Again, my eye should see that I have a negative exponent. That's a no-no. I also need you to understand that this is x to the negative 7th power over 1. To get rid of the negative exponent, I am going to flip this fraction. So what that looks like is the 1 is on top in the numerator. The x goes on bottom, and now my exponent goes with it, but now it is a positive 7 because I flipped it. The negative sign went away, and this would be my final answer. Example 2, though, is a little more tricky. We have 7x to the negative 3rd power divided by g to the negative 2nd power. Well, if I look, the x term has a negative exponent. The g term has a negative exponent, but that 7 does not, so we're not messing with the 7. Leave the 7 alone. It's not being bothered by anything. Okay, so all I need to do is I need to flip the g to the top, the x to the bottom, and their exponents become positive. So the 7 stays the same. The g gets to come up top. Now it has a positive exponent of 2. The x goes on bottom. Now it has a positive exponent of 3, and that would be simplified. Now I do have more examples just to show you some difficulty levels. I need you to remember that there is always more than one way to solve a math problem. So just because I am solving it one way does not mean your way is wrong. That's something that we just need to understand. Okay, so looking at example A, first let's read the directions. Simplify each expression. Your answer should contain positive exponents, meaning no negative exponents. I just showed you how to get rid of them. Okay, so again, more than one way to solve a math problem. I'm going to show you just the way I would do it, processing it. So right now I have m to the 4th times 2m to the negative 3rd power. I'm not going to worry about that negative right now, but you could. It's not going to hurt you if you do or don't. But what I'm going to do is I'm going to do the product of powers property, where I have the same base being multiplied and I just add the exponents and see where I get from there. As far as numbers go, I multiply them like normal. Nothing's changing. Our basics never change. So I have 1 times 2, I get 2. I have m to the 4th times m to the negative 3rd power, so I'm going to add 4 plus negative 3. Well, 4 plus negative 3 turns out to be a positive 1. Therefore, I have no more negative exponents, so I have 2m, or I have 2m to the 1st. They are the exact same thing. It doesn't matter how you write it. Looking at example B, okay, on this one I notice negative exponent. How do we get rid of it? We have to flip it to the denominator. Well, right now, it doesn't look like a fraction, but if I put it over 1, it's now a fraction. All I'm going to do is take this whole thing right here, and I'm going to put it in the denominator, and the 1 gets to go to the top. So what that looks like is I have 1 over 2x squared to the 4th power, because now the exponent is positive. But I'm not done. There is always more. I now have a power of a product property, meaning I have 2 things in parentheses raised to a power, so I need to distribute that to every single term. So what that looks like is I have 2 to the 4th power, and then I have x squared to the 4th power. So I do need to multiply that out. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So I get 1 over 16. Here I have a power of a power property. So I have an exponent raised to an exponent. I multiply 2 times 4, I get 8. So I get x to the 8th power. And that would be my final answer. So you can have multiple properties within one question, and it doesn't matter the order you do the properties in. You will get the same results as long as you're following them correctly. Now, looking at this next one, this looks like a real fun one. So we're going to take it step by step. I'm going to start by simplifying the inside based on things we know how to do. So right now, I'm going to look at the numbers 24 and 16. Both numbers are divisible by 8. So I'm going to divide both of these numbers by 8. So 24 divided by 8 is 3. 16 divided by 8 is 2. Now I go to the x's. So let me change colors so you can see. So now I'm going to talk about these x's right here. The same base, they need to be subtracted because I'm dividing. So that is x to the 4 minus 2 power, and 4 minus 2 equals 2. It's a positive one, so it gets to stay up top. Okay, now I move on to the next variable, my y's. I have y to the negative 4 power and y to the negative 3rd power. They're being divided, so we subtract their exponents. So that gives me y to the negative 4 minus negative 3. Well, we all know that 2 negatives make a positive, which gives me negative 4 plus 3, and that is a negative 1. Well, right now that would be in the numerator. I don't want a negative exponent, so it falls to the denominator. Just like that. Moving to our last variable, we have our z's. Okay, so we have z to the negative third power divided by z to the fourth power. So negative 3 minus 4. That gives me z to the negative 7 power. Again, it's a negative exponent. So I go ahead and I flip it to the denominator to make it positive. I cannot forget that I have the cube on the outside, so I have to make sure every single term gets raised to the third power. Again, if it's a power to a power, I multiply. So 3 to the third power, that gives me 27. 3 times 3 is 9, times 3 is 27. X squared to the third power, I multiply. 2 times 3, I get 6, so I have x to the 6th. On the bottom, I have 2 to the third power. 2 times 2 is 4, times 2 is 8. Y to the first to the third, 1 times 3 is 3, so I have y cubed. And then z to the 7th to the third, I have 7 times 3, which is 21. And this would be my final answer. There's nothing left to simplify. So this is the video on properties of exponents.